All right, welcome to a new episode of. I was about to say Account Abstraction. Completely forgot the name of my show as I'm about to introduce it. Welcome to a new episode of Protocol Explorer. Today we're going to be talking about Account Abstraction with my friend Dan over from Alchemy. We're going to be exploring the Alchemy Accountkit. Dan, if you could give you a quick intro to yourself, what you do, and what brought you here, yeah.
It's so funny because I feel like I do that all the time. I have so much context in my head that I go to say the most basic thing, and I'm like, wait, what? Where am I? Protocol Explorer. It's you are the Protocol Explorer, right? When you named it, because
Yeah.
you are technically the person who is exploring the protocol in this instance. So that is you. That's your. So, yeah, I could give myself a little bit of a background here. So for those of you who don't know me, I've done a lot of educational efforts. Before Alchemy, I was working on ChainShot, which is an Ethereum developer bootcamp, where we graduated a whole bunch of students who could learn everything that you need to know to be an effective developer in the Ethereum ecosystem. And now we're applying a lot of similar education to Alchemy University. If you haven't been there, check it out. Go to alchemy.com/university. It's a great place to get started, even if you don't know any programming. But if you do know programming and you're just coming from Web 2 and you want to get into Web 3, also a great place to start. We're going to be adding more stuff on account abstraction, all that sort of stuff soon. So really cool stuff coming your way. And yeah, that's a little bit of a background about me.
Awesome. Thanks for that, Dan. Yeah, so today we're going to be talking about account abstraction. We've done account abstraction kind of on the stream before. If you've been following me, you know I've been around in the account abstraction space as well. But Dan, would love to have you kind of take it off and get your thoughts on this side of things.
Yeah, absolutely. So with account abstraction, at the end of the day, so I want to take you guys back a little bit before we dive into what we're going to be doing here. So I know typically on the show, I come in and then Rahat codes a little bit. So I come in and explain something, and then you go and code. But I want to take us a little bit back first and talk about account abstraction a little bit more generally, so that we can understand what is actually being accomplished here. So to do that, maybe first, so I want to define account abstraction with some slides and kind of go through it. Maybe first, so Rahat, you know just as much about me as account abstraction. Do you want to give maybe your definition or your TLDR for account abstraction? If somebody who's a Web 2 developer who's just starting to understand Web 3 is what is account abstraction? This sounds like a really vague term. What does that mean? What do you typically tell somebody?
Yeah, I mean, in different workshops and stuff that I've done, I've defined it as sort of looking at a transaction and adding some additional verification logic to it, or any action that you can take. Is there something you want to check? Is there some type of verification you want to do before allowing that interaction to actually complete? um, so maybe you want to verify whether someone is going to pay the gas on behalf of the end user, or maybe there's a bunch of different interactions or transactions that need to come together along with that one. Um, so it can really be just a bunch of different arbitrary logic that you add on top of an interaction. I would say interaction if I were talking to a Web 2 dev, just because maybe they might not like the word transaction as much. Um, but yeah, generally for Web3 folks, I'll just say, yeah, before we do a transaction, there might be some logic we want to execute first before allowing that transaction to go through.
Wow, that's great. That's actually very, very similar to what I usually say. I try to really harp on the word flexibility, because
Mhm.
it's the EVM. Basically, what I'm going to show in some of the slides that we're going to take a look at in a moment is the EVM historically has been very inflexible in terms of how we can use accounts in the EVM, and we want to add some more flexibility to be able to do the things that you were describing, the verification. We're going to talk about gas abstraction, the payment abstraction, but also signature abstraction. How we want to be able to make smart contracts kind of our generalized account. And that's really what we're trying to get to with account abstraction. So I want to break it down, make it really, really simple, and then we'll dive into some code and do some fun stuff from there. So yeah, let me go ahead and present some slides so that we can get a good feel for this first. And Here we go. Entire screen. There we go. Cool. All right, we see ourselves, the infinite recursion. Cool. Okay, sweet. So account abstraction, like it sounds so abstract, right? It sounds like a big name, and it is, and I think it's a really hard one to define. And I kind of put you on the spot there, Rahat, to define it, because it's a really hard one, and I think most people would struggle to explain it, even if you spend a lot of time in this space, succinctly in a short sentence. And that's because it has so many features that we are enabling through a set of proposals that are defined in account abstraction. We're going to see that there's many different proposals. I'm going to touch on a few of them, but go down really one mainstream of account abstraction. But really, this is a very big topic encompassing many, many different proposals that are going to change potentially the protocol, potentially smart contracts inside of EVM, and we'll take a look at how that all works. So the first thing, to just be like a little bit more concrete, what I like to talk about first with account abstraction, because like if you're coming in here, it's a big term, right? But what I like to talk about first is the reason why a lot of people are talking about account abstraction now. The number one feature that it unlocks that people are excited about, that are starting to move into account abstraction, is this idea of gas sponsorship. Now, I want to highlight that this is just one of the features of account abstraction, but this is the biggest one that people are excited about. This idea that essentially you could have a user who's over here with their key. You see them over here on the left-hand side, and they are sending something into the EVM. And I'm being very vague here because I'm describing multiple proposals, as we'll see in a moment. Depending on what proposal you go down, whether it's native account abstraction or ERC 4337, that we'll see in a moment, this is set up a little bit differently. But you could have a user who is sending some sort of an intention on chain. They're signing it. And then what's happening inside of the Ethereum virtual machine is a smart contract account is then going to make some state changes, but there's a paymaster on chain who is willing to spend money, that's willing to pay and sponsor for that user's transaction. Now, this is a really interesting new unlock, especially now that we're getting into the space of like transactions being so cheap, right? We're getting to the point where L2s are making it super, super cheap for users to transact on chain, such that it actually makes sense in a lot of business use cases to actually sponsor your users' gas. So now the industry is kind of going through that idea maze of how does it make sense to sponsor users' gas? In what instances do we want to sponsor users' gas? Is it only on onboarding? Is it all the time? Like, what's the business models around these different use cases? So it's a super interesting area to be in, to watch what everyone is building inside of account abstraction. But this is the number one feature that you're seeing people start to really want to try to incorporate, is this idea of actually paying for users' gas. So at the end of the day, for the user, what they get to have is they come into an app and they use a private key, or they have a private key associated to some login. Maybe it's like a social auth or something like that. They click a button to log in, and then they could just start clicking buttons on the website that may be doing on-chain actions behind the scenes, even though they are not paying gas, even though they might not even know they're doing on-chain actions. It's just doing it seamlessly as they navigate the website or the application. So this is a really cool unlock for account abstraction. Like I said, I wanted to make it concrete with a super simple feature. This is something we'll see in a moment, is gas sponsorship. So we'll come back to that as well. Now, to take a step back to what I was talking about a moment ago, which is this idea that EVM historically has been really inflexible as far as accounts. This is the big thing that we're trying to correct when it comes to account abstraction. Is before in the EVM, there was really two accounts. There was the externally owned account and a smart contract. And with these two accounts, the externally owned account is a private public key pair. So you have a private key that you need to keep safe. You sign transactions with it, and then on chain, it is recovered into a public key, which is then turned into an address. So saying that this private key controls this particular address, right? And then you can actually make state changes on behalf of that address using some of these transactions that you've signed with your private key. Because of this, the externally owned account can initiate transactions, whereas a smart contract cannot initiate transactions. It's just a blockchain program. It is just code that lives on chain. So it does not have this ability to initiate transactions. So because of that, you have sort of this this dichotomy. You have this like breakdown where the externally owned account has certain features, smart contract has other features, and we sort of want to merge these two, when it comes to account abstraction. And that's the way I like to think about it, is like sort of merging and getting the best of both worlds on both sides of these accounts. So we want to be able to get full account programmability so that our externally owned account, so that we have an account that can sign transactions, it can initiate transactions, but it can also have full account programmability. So what that's going to do is this idea of a smart account. So I'm calling it a smart account here, which is like a smart contract that is an account. It acts as an account for us. It has this ability to initiate transactions, even if that's in a meta sense. We get this ability to have full programmability in an account, which, as opposed to an externally owned account, historically, most users in EVM ecosystems only have an externally owned account that you might secure through a mobile wallet or MetaMask, something like that. And when you have an EOA, you can't do things like respond to contract calls, right? So like if an NFT contract wanted to call out to your EOA and say, hey, is it safe for me to transfer this NFT over to you? In other words, are you ready to accept this NFT and do you know how to handle it? The EOA can't respond to it, right? Because the EOA doesn't have any code. So there's a number of different things that you could potentially do. This is just a really simple example, but there's a number of different things that you could potentially do when you have an account that can actually integrate with other smart contracts in the ecosystem. Another really good example is like pull payments. So if you wanted to do a subscription where you said, I subscribe to this particular smart contract, that smart contract can potentially pull funds out of your contract, because with a smart account, you have the ability to write code to say, yes, this person can take funds out of my account. So responding to contract calls is a big feature. New validation rules. So another big thing when we talk about account abstraction is signature abstraction. So this ability to be able to do new types of signatures. So a passkey is a really good example of this. And then also the ability to change the security around your account. Something that really kind of sucks about like the EOAs that I have today. I've had them for many, many years, and they've built up a history of things that I've done on chain. But today I have to have that EOA secured the same way I did, let's say 6 years ago when I created the EOA, because the EOA is just a private key controlling the account, right? If I wanted to make that account more secure today, I really have no other option. I could transfer that private key to a different wallet potentially, although that's kind of a scary process for anyone who's done that. But I don't have this way of being able to like change my account's ability to initiate transactions such that I can get like multiple signatures, or I could have like some hot assets and some cold assets and be able to break up my account in that way. So that's something that we want to see from account abstraction as well. And then a smart account versus a smart contract. So what we're going to build this idea of a smart account versus a smart contract. In a smart account, you get this ability to be able to pay for gas with a smart account or have it sponsored for you. So in the old way that we see on the left-hand side, you had an EOA that pays for the gas. And so it's going to execute something on behalf of an account. So you might have a smart contract on chain that you say, this is my smart contract account, and it holds funds, and you want to be able to transfer something from that account. You have to keep track of, as a user, two different accounts here. You have the externally owned account that pays gas, and then you have the account on chain that holds funds that you want to be able to move funds in between these different accounts. But in this new way, what we're going to see is, instead of having an EOA that pays gas, we're going to have an EOA that's really just a private key that is signing something that then the smart contract is then going to be able to execute and validate, like Rahat was talking about a moment ago. The smart contract will be able to say, yes, that is a valid authentication. It is a way to actually be able to run transactions on behalf of the smart contract. So we can kind of move that validation logic that Rahat was talking about into the smart contract itself. So we only have to manage one address. We only have to manage gas in one account, or maybe we don't have to manage gas at all if a paymaster is sponsoring it for us. So the new way is using this new single unified account. And that's going to be what we're going to be talking about with the smart account. So there's a lot of different numbers with account abstraction. I'm not going to go into all of this, but I wanted to just make you aware of it. For anyone who's viewing this and who's not very familiar with account abstraction is something that's been researched for a long time, going back to like EIP 86, which is something that Vitalik proposed in, I think, like 2017. So this goes way back a long ways when before anyone was really thinking about this. And then EIP 2938 came up with this way of being able to do account abstraction, bake it into the protocol to get a lot of the features that we were talking about just a moment ago. There's also 3074, which you'll see you've probably heard a lot about, especially most recently, because it's potentially going to be included in the next hard fork. That's something that's still being discussed. So this is another thing that you will see quite often. EIP 3074, interestingly enough, is sort of recognized as part of the path of being able to migrate off of externally owned accounts, whereas 4337, which is what we're going to be talking about, it has to start from the get-go of everybody being at smart contract accounts already. So subtle distinction there. We're going to be talking mostly about ERC 4337. You'll notice I labeled it there as ERC. This is because it's a proposal that does not require protocol changes. So it's actually smart contracts that enable all the things that we were talking about. And then there's also a lot of efforts that eventually we want to get to this native account abstraction, which is a roll-up proposal out there called 7560 that's being adopted by some roll-ups that allow us to do 4337 compliant account abstraction with 7560. So if you're just coming into account abstraction and I'm tossing all these numbers at you, you're probably a little bit overwhelmed. And I don't blame you. There's a lot more numbers where that came from. But I just want to say we're going to be focused on 4337 in this. So I want to set the stage that this is only one specific flavor of account abstraction. It is the one that we're going to be moving forward with in this discussion because it is the one that's getting the most adoption at the moment. And it's something that we're going to likely see even when the account abstraction is baked into the protocol natively, like with 7560, we'll see account abstraction that is compliant with 4337. Okay, so let's focus on 4337 real quick. Just going to run through this kind of like the roles of 4337. This is what 4337 looks like. Again, I said it's account abstraction without protocol changes. So what that means is we're going to build smart contracts that allow us to do the things that I talked about, getting gas sponsorship, being able to do signature abstraction, being able to programmatically respond to contract calls with our smart contract account. So in this image right here, I'm going to break down each one of these roles in a moment. So I'm not going to go too deep into it, but what you can see is there's two keys that are off chain, right? You see the key for the user on the left-hand side. Then you have something called the bundler, which we'll talk about. You have an entry point, which is a smart contract that's going to handle the gas accounting. We'll talk about what that is. We have a paymaster who's potentially going to sponsor the user's gas. You have a smart contract wallet that is you can think of as your account as a user that's trying to make some state changes. So the 5 roles of ERC 4337 is going to be the user, the bundler, the entry point, the paymaster, and the smart contract account. So the user and the bundler are both going to have keys. The bundler is going to act kind of like the EOA used to. The user is going to just have a key for signing something. They're not actually going to necessarily pay gas. At least not out of their EOA as we traditionally think of it. They could potentially pay for gas out of their smart contract account, but most likely, in most cases in account abstraction, the paymaster is sponsoring the gas in a lot of the cases that we see today. So state changes without account abstraction looks like this, right? So this is your typical flow. If you have MetaMask, a hardware wallet, or a mobile wallet, you have a private key that's managed by the wallet. You submit a transaction and you make some state changes on chain. Super, super simple, right? It's all baked into the protocol in all the EVM ecosystems that we know of today. So this is like the traditional way of doing it. Unfortunately, we saw all the shortcomings of the externally owned account. So we want to move towards something where we can actually get some of these features that we talked about. So how do we move our account on chain? We can introduce a smart contract that we put on chain. However, what this creates is a situation I described earlier, which is now you have 2 accounts, right? You have the externally owned account and you have the smart contract account. Now you have to, as a user, keep track of both of these accounts. They're 2 different addresses. And you also have to keep gas money in the EOA, and you have to keep money in the smart contract account. That's the assets that you care about. So it becomes really cumbersome at that point. So how do we avoid being the EOA? How do we avoid paying for gas? We introduce another off-chain component that's called a bundler that's actually going to sign the transaction for us, because the protocol requires, at least in the original, in the current version of the EVM as it's adopted by most chains, the protocol requires that you sign something saying the only way you can initiate transactions is through the EOA, and somebody has to pay for that gas. So when we are doing just smart contracts to try to get account abstraction with 4337, we introduce a bundler, and the bundler is going to pay for the gas for the user. So now the bundler has to pay for the gas. However, the bundler is a off-chain component that doesn't really want to pay for gas. It's not a paymaster. It's not just going to freely sponsor users' gas. It should be a open source piece of technology that anyone could run, that could be run across many different ecosystems. Its intention is mostly to be able to sign transactions, make sure that it could do so in a way that it is going to get paid back for the gas. So we need to introduce something that is going to make sure that the bundler is going to get paid back at the end of the day. So we put another smart contract on chain whose main purpose is to make sure that the bundler gets paid back, right? So this way the bundler can actually sign the transaction for the user, and the entry point is going to make sure that the bundler gets paid back all of the gas that was spent. So in this image here, what would happen if we tried to send a transaction in this image is, at the end of the day, the bundler would sign the transaction. The entry point would make sure that the smart contract account pays the bundler back for the gas that was spent. But if we wanted to have our gas be sponsored, we can introduce one more contract on chain, which is called the paymaster. And the paymaster can conditionally say, I want to sponsor that user's account. This is important because, like I said, in account abstraction today, the main reason why a lot of folks are looking to use account abstraction is because of this new feature, this ability to be able to sponsor transactions and all of the things that unlocks. So the paymaster is a new smart contract that's usually paired with a server, an off-chain component, and the server will sign something saying, yes, I'm willing to pay for this gas, and then the paymaster will recover, make sure that that is somebody who is willing to pay for the gas on their behalf, and then this whole thing can happen on chain where the paymaster pays back the gas. And so as a user, you get this really nice experience of being able to just click a button and then something happens on chain, right? And maybe your private key is just tied to a Google auth, or maybe it's just tied to an email, or maybe it's just tied to your MetaMask key, but it's just holding it as a key and you're not actually paying for gas. So again, there's just 5 roles in ERC 4337. You got the user, the bundler, entry point, paymaster, and account. 3 new smart contracts. The account is really a flexible piece of code that we can put whatever we want to put into it. And then the entry point and the paymaster have those specific roles that I mentioned. And the bundler is trying to basically move the role of the EOA away from the user. So all the user does at the end of the day is sign something that's authenticated and validated by the smart contract account. So more technically, this looks a little bit like this. I do need to talk about this, just a couple more slides just yet. More technically, it looks a little like this, where users send operations. So we're going to talk about this idea of a user operation. We're going to see this in a moment. Rahat is going to program a user operation in using the AA SDK. So users are going to send user operations to a bundler. It's called a bundler because it accepts many user operations. It takes all those user operations, puts them in a transaction, and then sends them off to the entry point. And then the entry point for each one of these operations is going to go through, it's going to verify, it's going to go to the paymaster, make sure the paymaster is going to pay for it. Then it's going to call out to the account. The account is actually going to make those state changes that we expect to be able to make. That's the real transaction as we like to think about it, right? So like, if you were trying to interact with Uniswap using your smart account, you would be doing step 3 here, right? The state changes that you're trying to do is interact with the Uniswap ecosystem, you interact with some Uniswap pool somewhere. So that's what you're trying to do in that gray box there, right? So we're setting all of this up so that you can be able to do that there at the end of the day. And then the paymaster gets called back at the end of this. So that's what we're really trying to do with 4337. We're trying to send these user operations. User operations you can think of as transactions, but they're just they sign the intent of the user, but they don't require the user to spend any gas. So they have a lot of the same fields, and I highlighted some of the same fields. Although paymaster info is not one of the fields that would be in transaction. So I guess these fields are just ones I wanted to really talk about here. But this user operation is similar to a transaction, it's kind of like a meta transaction. It's a transaction that we're trying to get on chain so that we can actually make those state changes, right? So in that gray box, we could say, this is what we're trying to do. It's as flexible as a transaction, but it doesn't actually have to pay for any gas. That's actually done by the transaction itself, at least not at the protocol level. There is still like gas that needs to get paid back to the bundler via the entry point at the end of the day. So many users are going to send many user operations to the bundler. The bundler is going to bundle them all up in a transaction and put them on chain. So the job of the bundler is to collect many user operations, verify those user operations, sign them in a transaction, send them off to the entry point. That's the job of the bundler. However, it's not all the bundler has to do. The bundler actually has to be a really robust piece of infrastructure. And Alchemy has an open source bundler called Runler, which you can find written in Rust. And this piece of software has to be really smart in the sense that it needs to go out and simulate each user operation as it comes through to make sure that this is actually a valid user operation, and needs to be able to figure out whether or not it's going to get paid back for gas at the end of the day, because the bundler doesn't want to have to pay for any gas, right? It's just a piece of infrastructure that is trying to send transactions for us. But at the end of the day, it needs to get paid back by a smart account or by a paymaster, one of those on-chain components. So it's going to go through and simulate user operations as it gets them. And then it takes these user operations and actually bundles them in a transaction and puts them on chain. So executing user operations looks like this, right? You take those user operations, you sign them in a transaction, and then at the end of the day, the account is going to make those state changes in that gray box. That's what we really care about. All right, great. Made it through all the slides. That was a lot. So I wanted to do all of that so we could actually just get into what we're going to be building. So we're going to be trying to do two things with the time that we have available. So I don't want to go over in time. I know those slides took a while. For Accountkit, when it comes to Accountkit, what we want to do is we want to make it so that for devs, it should be just as easy to send a user operation as it is a transaction. So if you're sending a transaction today in your application, whether it's a server-side application or front-end application, web application, web app, you want to be able to send a user operation just as easily as you would send a transaction, right? Make that tooling super, super easy to be able to do it, because at the end of the day, a user operation, the core fields of a user operation are the same ones that we care about for a transaction, which is what smart contract are you interacting with, or what address are you interacting with? What call data are you sending if you're trying to target a method on a smart contract? And what value are you trying to send through if you're trying to send some native currency through, right? So for devs, we want to make a user operation just as easy as it is to send a transaction. For users, it should be even easier to get on chain because of all the things that we talked about, right? The flexibility that you get from a smart account is going to make it so that users at the end of the day can get the kind of user experience that they want. We get this flexibility to be able to program in all kinds of new user experiences, whether that's the gas-free user experience I talked about just a moment ago, or being able to do things like session keys, like limited time privileged access keys to a smart contract account. You could program whatever you can imagine because now we have that flexibility. So we're going to do two things. One, we're going to send user operations from a local script. So again, these user operations are those intents that we're trying to get on chain. And then we're going to do it from a Web3 app with an embedded smart account. So that smart account is going to be something where a user can sign in through an email address, and then they can just start sending user operations right away. So that's going to be that experience that I talked about, which is a user getting on chain and they could just click a button and be able to do things on chain really, really easily. So a user doesn't have to worry about managing their private key. They don't have to worry about gas. They just want to do something. They just want to use your application and get started, right? This is going to be a lot of what we expect mainstream to do is just want to get used to an application before they think about how it's secured. So some of the resources here we're going to be taking a look at. AA SDK is the open source SDK that Alchemy puts out for account abstraction. So we're going to be using this in a moment. Rahat is going to be installing this and we're going to be running through with it. The Accountkit is a larger name for these tools that includes the AA SDK. And then I have this AAA starter that we'll take a look at the end here, which is going to allow you to do the second thing, which is going to be start up a Web3 application, use an embedded smart account so you could start sending operations on chain. So some helpful resources there. Awesome. Okay, so that is everything that I wanted to get through here. So how are we doing on time? Man, I took a half an hour. I was aiming for 20 minutes. That took longer than I expected. I
No,
guess
I think that was still awesome. No, I love the examples you gave. I feel like definitely the gasless transaction or sponsored transactions is like one of the biggest use cases that a lot of people just like find like that aha moment with when we're doing a lot of this stuff. Especially now with like a lot of L2s, lowering fees. I feel like gas costs has just come like eventually will just become like sort of an infra cost for dApps to just like operate for like their end users to just be able to use them. Yeah.
Yeah, I'm excited for those days. Honestly, I came into the space mostly because I was excited about education and I just saw a really cool opportunity to help like educate developers and empower developers.
Yeah.
But when I learned about like Ethereum and everything, I was really excited about the non-financial use cases or like financial adjacent use cases.
Yep.
And I think we're going to start to see things like that, hopefully, like with what you just described, which is like thinking about it as like an infra cost, thinking about it as a overhead that you have to incorporate into your business model. And what kind of businesses can we enable through that? I think it's just like there's a lot there that still needs to be thought through. It's difficult. It's not easy to do this stuff, but it's getting easier. And I think there's a whole bunch of cool stuff we can see and starting to see.
Definitely. Yeah. Cool. So let's dive into things. I'm going to share my screen.
All right.
Got the
My turn to
account
sit
bit.
back.
Okay.
Cool. So yeah, so Rahat, for this first part here, maybe so what I was thinking would be easiest is if we could just start sending user operations through a local like NPM project.
Hmm.
So like if you want to start like a new NPM project, then we can install what we need from the AA SDK because it's broken into a couple different packages, but I think we only need 2 of them. So yeah, if you pull up like a new project, we can try that out.
I don't know what happened there. Okay, cool. I'm just going to go into here. Okay, cool. We want 2 of these.
Let's just so I have a starter repo that I'll
Okay.
do for the second part, so we could just do one.
Okay, cool. Awesome. So I'll just do npm init.
Sweet.
That is not what I wanted.
I do that all the time.
That's not what I wanted at all. Okay. That's what I wanted.
There we go.
Cool. So we've
Sweet.
got our just basic node project ready to go.
Okay, so have you used VM before, by the way?
Yes.
Okay, so maybe so can we go over the hour or no?
Yeah, we can go a little over.
Okay, because I can. I just want to make sure that we budget time accordingly. Because
Mhm.
maybe what we can do to kind of just sort of set the stage a little bit. So AASDK is built on top of VM, so it has similar concepts. So the client is the thing that you're using to like sort of route your calls to the RPC and to the bundler. In this case, when we talk about account abstraction. So if we start with VM first and just show an example with VM, then we can kind of compare it to what we're doing with AASDK and be able to just see those changes. So if you want to do first, maybe we can install VM, which should just be, yeah, sweet. And then we could start with just like a simple example of maybe sending a transaction with VM and kind of go from there. So, okay, cool. So how do you like to do async functions, by the way? Do you do like the async iffy?
Yeah.
Like,
I
okay.
usually do async await.
Okay.
So like yeah.
Awesome. And how much you are the protocol explorer. So how much should I be how much are we sharing code? How much do I give you? Do I prompt you entirely? Do we kind of go back and forth? What's
We
the
could probably go back and forth a little bit. Yeah.
Okay. So what I want to do here is I want to be able to send a transaction with VM. And how do you handle a lot of questions from my end? How do you handle API keys on the stream? Do you just Do you have an Alchemy account that if we wanted to go get
Yeah.
like an RPC URL? Because I can just share one with you if that's easier, or if you want to pull one up. And I don't know if you care to like
Yeah.
put a .env or yeah.
I mean, if you've got one that you can share for the workshop, that would probably
Yeah,
yeah.
I like delete these immediately after, but yeah, here we go. Let me get one real quick. That's always something. So in all of mine, I'm always creating private keys, and I'm always just like, please don't use my private key. Especially live stream. We had when I was doing the Ethereum developer bootcamp, you know, the student may be watching this right now. I had a student who so here we'll do Arbitrum Sepolia because I just find that to be fast. So let me see if I can send this over to you. Ooh, I don't even know. Should I send it to you via Telegram? How do I send it to you on here?
There should be a private chat in
Okay.
StreamYard. Yeah.
Ah, sweet. Just have to back out there. So this is my API URL. So we might need, yeah. So we'll use the API URL for now, and then we could use the API key for ASDK.
So I can just paste this on here, right?
Yeah, go for it, and then I'll delete this afterwards. So we'll use Arbitrum Sepolia. I just so to tell you the story. I had a student in the Ethereum developer bootcamp when we taught it with ChainShot, who in the middle of my demo was copying down my private key and like pulled all the cash. So by the time I actually went to run the script, it was all gone. I was like,
oh no.
And I went on chain and I looked at it and I was like, who did that? So I'm always like, yeah, somebody could do that and pull it out from you. But fortunately, I got a good error, so I knew. Okay, so there's our API URL. So with VM, there's sort of this idea of like a wallet client that we can import, and the wallet client is going to give us wallet actions, because in this case we want to like send a transaction somewhere, and I think to make it fun we should do a smart contract. Maybe we could use like Remix or Hardhat or Foundry. I don't know which one you want to do, but we could put it out into
maybe just for expediency.
Yeah, Remix is usually my go-to for that. Did you see
Something.
they just added I saw this yesterday. They just added like Copilot into here, which is pretty
really?
cool. Yeah.
Did not know that.
So yeah, that works perfectly fine.
Okay.
So you call it whatever, and then we'll just basically all I want to do is have a contract that we can like just change a variable on it. So like I usually just make a public uint x or something like that. And then, make a method so that we can actually change that variable. Basically all we want to do.
Okay. What if I just have like a counter or something here?
Perfect. Yeah.
Probably don't. All right, let me just copy this over. So we'll just make a counter, I guess.
Yeah, exactly. Just something so we could target a method with some call data, because that makes it interesting, right? Otherwise, we're just sending a blank transaction.
Yeah.
Which is kind of lame.
Okay. So give me 1 second. Okay. How do we want to do this? Okay. So I'm getting performance anxiety just a little bit.
Sorry. Yeah.
This is
tough. I can't believe you put yourself through this. This is like a nightmare for me. Just get somebody on the stream and be like, do this. This is scary.
So I'm just going to create a public variable. Crap, hold on.
No worries. Yeah, and then so public would be on the other side. Yeah.
That like context switching between JavaScript and Solidity always gets like me.
Yeah, absolutely. I feel you on
that. Increment, we'll call it.
Sweet. And then we could probably toss an external on there. I think that's all it's complaining about. Yeah. I just got to toss it on the other side of the parens.
Yeah.
Just one more over. Sorry, on the other side of the
Oh, yeah.
parenthesis. Yeah, no worries. I think you would
Accumulate
figure
solidity, guys. I promise. Should it return the count or no?
No, that's okay. We just want to modify it, really. And the fact that you made it public is perfect so that we can just go test that it's
Yeah.
actually working. So this is all we want here. So we're good. We do want to deploy this onto Arbitrum and Sepolia just so we can have a live example and be able to view. There's a really great user operation explorer I want to check out. Hopefully we can see that at the end here. So I don't know if you need the chain info or if you happen to have Arbitrum and Sepolia. I do have some ether for you on the chain.
I think I may need some ETH.
Okay. Yeah, I got you there.
But I do have everything connected for Arbitrum and Sepolia.
Sweet.
I'll send you my address in the chat.
Cool. All right, sending over life savings. Here we go. All right, I'll do 0.05. That should be plenty.
Yeah.
It always throws me off. I don't know if it's a setting in MetaMask when it shows like the real dollar value in there. I'm always just like, wait, where am I? I think it's a setting, so I can actually just turn that off. Makes me nervous. But yeah, you should have the 0.05 over there.
Okay, just got it.
Sweet.
Cool. So this is compiling. Wonderful. Let's deploy it. MetaMask. I think I'm already on. Connect. Arbitrum Speller. Okay, cool.
Sweet.
Let's deploy that. Confirm. I see. So Solidity Copilot not activate. I guess gotta activate that.
I think we're good. I see a contract down there in the bottom left, deployed unpinned contracts.
Oh yeah.
Yeah, so that's probably it right there. I
Oh,
think.
no, I was referring to like the Copilot. You mentioned the added Copilot.
Oh, sorry.
Yeah.
Yeah, I think it's a top. So just above the code where you are, above your license identifier, there's little buttons for the AI.
Ah, okay, cool.
Yeah.
I'll play around with that later.
Yeah, it didn't do much right away for me, so I don't know if it's still got to activate, get used to me. It's got to learn me a little bit.
Gotcha.
Cool. Okay, so we have the contract out there, which is perfect. So if you want to copy that contract address, maybe we can grab that and then we can start to increment first with VM and then with the AA SDK to be able to see that. So yeah, perfect. Awesome.
Cool. Let me start bringing in all the VM stuff we need.
Yep.
Is it equals require VM, right?
Yeah. Yep.
There we go. All right.
I believe create wallet client would be on there. Let me just double check. I have. Yeah, there's a create wallet client that we can pull out of there.
Cool.
Sweet. And then that's going to be asynchronous. So if we could toss that into an IFI or something. Actually, that's not asynchronous. But what we'll do with the contract will be.
Cool. So I'll just do like a const start function. And we'll say that's an async function. And I'll just immediately call it down here.
So you could probably change the const to a function there if you want to do it that way.
Yeah.
Okay. Yeah, that works. Sweet. So annoying that there's two JavaScript ways of doing functions. And so you always do them like one of the halfway of one, halfway of the other.
Yeah.
Cool. So yeah, so we can create a wallet client here. So we can use that function and then create a client variable. And then I can tell you what we're going to need for that. Although they do a really good job if you can key into the documentation of it. Like they do a really great job of showing an example. Like I think my command for it is like control or command, and then you press on the create wallet client, and then it pops up inside there, and you can see their example code. And VM just does a really good job of that. I always find that this is the way I go, but we'll need, so we're going to need a couple things here. We're going to need the chain. So for the chain, we can, yeah, you can put in chain, and then VM spits out these chain definitions. So, stop me if you know this stuff, but Arbitrum Sepolia would be the one that we want to pull in, which hopefully if you start typing it, maybe it'll know to get it from VM.
No, it does not.
Never know. So it comes out of VM chain / chains. So we do have to, create another one.
Okay.
Yeah,
there we
now
go.
it's got it. Sweet. We can do that one there. Cool. I always just pick an L2 testnet because they're so fast. And yeah, that's always great. Okay. And then we need the transport, which is going to, it's going to be transport. And then we'll do HTTP, which is also a defined variable. That's going to come out of VM. Sweet.
Got it.
Yep. And then we can pass in our API URL into the HTTP as a function. And then, we can pass in our API URL. Sweet. All right. And then since it's a wallet client, we are going to need an account. So you can put the account there. And how should we do this? So somebody could drain our private key. How tricky are your viewers? Is somebody going to do it? All right. So what I like to do often for this is I'll just generate the private key on live, and then we could just grab the account. So what we could do is
I got a script actually for generating private keys.
Oh, sweet. Okay.
I can just go grab that real quick. I forget where I stole this from, but I stole this from somewhere. So
I always use the crypto library from Node.js. You could do like random bytes 32.
Yeah.
Oh, sweet. Okay. Yep. Same thing. Awesome. There it is.
Private key.
This is the private key. All right. So yeah, we could store that. And then if we, then there's out of VM, there's a private key to account that comes out of VM/accounts. So we can get that, and then we can actually get what the address is for the private key.
So VM/accounts.
Yep.
Private key to account.
Exactly.
And that would just take the private key.
Yep.
Cool.
Sweet. All right, now we have it. So maybe what we want to do is we want to figure out what the address is for that account first, so we can fill it with some gas money. This is the annoying thing that you no longer have to do with account abstraction, right? But we have to do it in this case, at least if we're getting it sponsored. So maybe first, if you want to first get the account there, and then we can log out the address, and then we can pass it into the account, or however you want to do it.
So I'll just call this the EOA.
Sweet.
And we'll just log out the EOA.
Sure.
I don't know what just happened there. Not what I meant to do at all. 1 second.
No worries.
You guys are seeing like random things that you shouldn't be seeing, but
I'm telling you, you like put yourself through like the worst nightmares. Like, get in here, tell me what I'm gonna like click around on my machine. I think if I had a random guest on my on a live stream and they told me what to do, they could probably be like, "Now go into your bank account," and be like, "Okay."
Okay. Is all right.
All right, and we could send that some Arbitrum Sepolia. So if you want to send it to me, I could do it, or if you want to send it.
Yeah,
we don't need that much in there, so
yeah, I'll send like 0.001 or
perfect.
Yeah,
you gotta be frugal with that 0.05 I sent over.
I'll send like 0.003 just in case.
Oh, there you go. Okay.
All right, so I'm sending that off screen, but just sent that there.
Sweet.
We should be
all
good.
Right. Yeah, cool. So now we could go ahead and write to our contract. So on the client, now that it's a wallet client with the wallet actions, we can do client.writeContract. And so this is, there's a couple different ways we could do it. Well, write contract works pretty well. Okay, so I'm just thinking, because I'm trying to do like the best comparison between what AASDK does and what we're doing here. So maybe we want to do more of a just like, I think there's a send transaction on the client, I believe. And that would just be like sending a raw transaction rather than using these. Yeah, let's do that one, because this is going to be the most similar to what we're going to build in a second. So if we do send transaction, we could pass in the data, and the value. And it might be 2, it might be target. I always forget. Sometimes these change, but
I think it's 2.
Okay, sweet. And then data. So we won't want to pass in any value because we're being very stingy with the 0.03 that we have there. But the 2 address is going to be the contract address that we want to target there. So that's the one that we're going to try to increment. And then the data, we're going to try to call increment. So how do you want to do this? Do you want to encode it? Or how do you usually do this? So we have an encode function data that we can pull from VM as well. I think that comes straight out of...
Is it here? Encode. Yeah, here it is. Encode function data.
Sweet. Okay. And so we could do that in the data field, and we could do encode function data, and then that's going to take, yeah. So what does encode function data take? I got the documentation up here just in case.
That takes a string, I think, right?
So it takes an ABI and a function name.
Okay.
So for the, so we could put in an object in here, and the first field we're going to do is ABI. And so for the ABI, we can kind of, instead of pulling the ABI over from Remix, which we could get, we could just sort of make a human readable ABI here. So if you do ABI, and then there's another method out of VM called parse ABI items, I believe, or parse ABI, I think is the, yeah, there we go. So this is going to take a bunch of ABI items, is what they call it in VM. And so it's going to take an array. And then in here, in the array, we could pass one string, which is going to be our sort of human readable version of the method. Yeah, exactly. So it'll be like function, and we called it increment.
I think so. One moment. Let me.
No worries.
Okay, here it is. Yeah, we called it an increment.
Sweet. Okay. So yeah, we could do that same one there. And then we can just do parentheses. And then I think, so it, yeah, maybe it'll just interpret that. Okay. Well, you might have to do parentheses just to tell it that it's not going to take any arguments. So on the other, on the other side of increment, I don't think you need to specify the visibility. It might just be able to parse that as is. I'm not entirely sure, but usually VM's pretty good about giving you like a TypeScript error which I don't know how they do that. That's like magic to me. But like if you put in an invalid ABI, it'll tell you somehow at TypeScript level. I'm like, what is even the code for that? But so there's ABI, and then the other thing we'll want to pass in is the function name. So so you'll do like a comma, and then the other on the level of the ABI, sorry. So this would be, so the reason why we need to do this one is because if the ABI was many functions, we would have to specify which one we're targeting. So it's like we fed in the ABI, so now we also need to feed in function name. Yeah, and so this will be a string that's actually the name of increment in this case. So we're basically telling VM how to parse it, and then we're also telling it this is the one that we want to encode for. So that should be everything. How do you feel? Do you want to, maybe we'll get back the transaction hash and then we could log it. I think that's what we get out of send transaction. I think that's what we get back from it.
Yeah.
So if you await it, then we should get back. Yeah. So I believe that comes back with a hash. It does. Okay. So if you want to log that out afterwards, then we can, yeah, we can see it. Perfect.
And then we'll just log out the actual transaction. Cool. Let's run that.
All right, let's do it. incrementing. Here
Let's
we
get
go.
rid of this so we don't have a lot of things printing. Okay.
Sweet. Okay, so,
Transition.
so here's the Sepolia Arbor I just sent over on the private chat, unless you want to just pull it up too. I always have to go searching for those, but this is the Etherscan for Arbitrum Sepolia.
Nice.
And so if we take that transaction hash, we can go find it. Oh, you found it already. Cool.
Yeah.
You're very fast.
Looks like we're good.
Looks like we're good. Okay, sweet. So if we go back to Remix and we press the count, we can just verify for the viewers out there that we did indeed increment this.
We did.
We did. All right.
It's very small, but it's there.
Sweet. All right. So we did the first one, which is to do this through a transaction, which was, a little bit annoying because we had to feed in the gas there. Now doing this with user operations is going to just take a little more configuration because we have to specify, we're going to specify what's called a gas policy. We're also going to specify, there's something else. As we get into it, I'll figure it out. But it's going to take a little bit more configuration than this. But outside of that, it's going to be relatively similar to what we did here. So do you want to, maybe we'll create a second file and then we can kind of compare the two. Does that work for you?
Yeah, that works.
Okay, sweet.
We had a quick question from Amar. Does Account Abstraction make it possible to pay gas fees one time for 3 transactions, for example? I love this question.
Yeah, that's an interesting question. So pay gas fees one time for 3 transactions, for example. So, okay, so the way that this works with sponsorship is that the paymaster specifies per each user operation, which is, again, that like meta transaction that we talked about. It talks about, it says per user operation, whether it's willing to sponsor the gas on behalf of that. But we do batch all the user operations into one transaction and that gets put on chain. So technically, like, you're sponsoring per user operation, but that all does happen inside of one transaction. What do you think, Rahat? Was that a good way to answer it?
Yeah, I think so.
Okay,
yeah.
Cool. So, it's tough. You spend all day in account abstraction and sometimes somebody comes up with another way of doing something and you're like, oh yeah, that's true. That works as well. But yeah, all user operations go in one bundle and we could sponsor it per user op. All right, cool. So for AA, we're going to use 2 libraries here. One is going to be AA core. So let's install these. So they will be yarn add, and it's going to be at Alchemy. So and then slash AA-core. And then one more that we're going to need is going to be AA-Alchemy. And so I'll talk about both of these packages in a moment and why we're using these 2 specific ones. There are, Alchemy, yep. And then slash, and then it's AA-Alchemy. Yeah, double alchemies. Cool. So AA-SDK is broken up into 5 packages. The team working on AA-SDK, all super, super smart engineers, and they are they've made this library super, super flexible. So AA-SDK is an open source library. You can go contribute to it. You can go see it. It's a really great library. It's broken up into a number of different packages because it has to be a super, super flexible library. Because we can't assume, with the AA SDK being an open source piece of technology, we can't assume that you're just going to use like the Alchemy bundler and the Alchemy paymaster, and everybody's infrastructure works like slightly different, and then you have to route it. And like there are things that we can do if we know that you're using all Alchemy components. So the AA Alchemy specifically, that one that we're going to use, assumes that you're using all Alchemy components. You're using our smart account, using our bundler, you're using our paymaster. That makes it really easy so that we can do like the least amount of work. But if you are trying to like mix and match components across different providers and use different accounts and things like that, there are ways to do it. And we have examples for that. It just requires the other packages. So that's why we have these 2 packages. That's why we're using them. AA core is going to have most of what we need in it, like the core things inside of it. And then AA Alchemy is going to have these things that assume that you're using all of our infrastructure, which we'll talk about in a moment as well. Cool. Okay, so what do we want to do? Right. Okay, so let's Do you want to just copy most of this code over and
Yeah,
then we'll just
I was thinking.
okay. Okay. Yeah. All right. So cool. What we need to do first is we're basically going to, instead of making a wallet client for VM, we can comment out that we are going to create a client, and it's going to be a VM client at its core, but it's going to be extended upon the VM client. And it's going to be something called I have this over here somewhere. It is called, the one we specifically want to use. Oh man, I had this up here somewhere. Oh, it's called a modular account alchemy client. Okay. So we're going to go ahead. So we can import that from, this is our AA.js, right? So we can import that from AA Alchemy. So if you do a const require, and then we could do at alchemy. Yeah. Yep. And then AA Alchemy. Yep. We could do, it's going to be called create modular alchemy account alchemy client. Whew. These names get really long.
Yeah.
So, but don't let it scare you. It's not too bad. So to break down that name, modular account is something that I did not talk about in the slides because as it was, the slides took 30 minutes. I thought they were going to take 20. But the idea of modular accounts is we're working on, there's a standard called 6900. There's a few different standards that are out there for different modular accounts that are in existence today. But the idea of a modular account is one that you can install arbitrary code to your account. So like I talked about this idea of accounts being really flexible so we can respond to like NFTs calling in and saying, is it safe to transfer, or a subscription payment? Those types of things are great ideas for plugins that can go inside of a modular account. So as a user, you could start with a really simple account, and then you can start to install plugins as you need more flexibility on your account. This is what I wish I had on all my EOAs. I don't know about you, Rahat, but like I have a bunch of EOAs that I've had for years, and I wish I had like the ability to like modify the functionality on that EOA to say like this, you know, like this is something that I always want to keep here. And this, you know, like these POAPs, I don't, you know, like, I want to lock down that account a little bit more than how it is now. But
I think
yeah,
one of my favorite use cases is like adding safeguards or recovery options to like compromised wallets. Because I've got a compromised wallet that I wish I could take some NFTs out of, but every time I send some gas to it, it
oh
gets all
no,
sucked up. So
oh no.
this would have been a perfect time to, add in something like this.
Have you looked into doing like an MEV rescue sort of situation? Like, have
Yeah,
you?
that's my next
Yeah,
next
that'll be a fun
next
thing
rabbit
to.
hole to go down.
Yeah, yeah. Record it. Don't do it live, but
Yeah,
record it and
I
then
am
do it
not doing that
afterwards.
live.
we had we had a student do that as a student project. Had
Okay.
like a compromise, and then a bot that was like taking the gas out of it, and that was a pretty cool one. Well, sweet. So okay, so we have a create modular account alchemy client. This is going to take some of the same parameters here. So we can kind of replace create wallet client with create modular alchemy client. Man, it's a mouthful. But okay, so there's a couple of differences. The chain, so you see Arbitrum Sepolia there. We do want a chain called Arbitrum Sepolia, but now we want to import this not from VM chains, but from Alchemy AA core, right? Yeah, it's an AA core. Yep. I'll tell you why in a sec. Yeah, sweet. And now we're going to want to take Arbitrum Sepolia out of there as opposed to the VM chains one. So this is a common mistake that I always make as well. TypeScript will tell you when you make this mistake because it just won't be valid. It doesn't have all the properties that we need. But we also define some other things that we need for like user operation, gas parameters, and things like that that also need to be defined on the chain. So we like extend the VM chains definition and then add some extra things in there. So we need to grab that out of there. Transport we don't need because like I said, with Alchemy, we are assuming that you're using like all Alchemy infrastructure, which is nice. So there's less configuration here. So we don't actually need to configure a transport. Instead, there's going to be an API key. So we can do, Yeah, you could do an API key field here, and you could just take the last part of my API URL I gave you earlier. And that's going to be the API key that we can use for this example here. Yeah, perfect. And then we can get rid of transport. And then for the account, now instead of account, we're going to, this one does need to change over a little bit. We're going to have to create, so it's going to be called a signer. So this is actually like, it's cool that the terminology changes here because it is different, right? So like before we were using an externally owned account and we were using it like an account where we had the private key signing transactions and then there was an address associated to it. Here we're calling it a signer because all it's doing is signing. Right? We're just signing something, but it's not actually the address associated to this account doesn't matter so much as just the private key and its authorization. So for the signer, we are going to need to pass in, it's going to be, there's a local account signer that comes from AA Core. Yeah, that's the one. And then local account signer is going to have a method called private key to account signer. Yeah, exactly. And then we can pass in the private key there. And then we can get rid of that account. And that would be it for the changeover. So it's very similar, right?
Mm-hmm.
One more thing that we do need to configure if we want to make this super, super simple, which is a gas policy. So a gas policy with Alchemy, you can set up you can go into our gas manager in our UI in our dashboard, and then you could get a gas policy ID, which is going to allow you to specify which transactions you want to pay for your particular application. Since I gave you my API key, I'm also just going to give you a policy ID. I just got to make sure I get the right one. So let me pass that over to you. And this will then sponsor our transaction. So behind the scenes, this is a Paymaster smart contract wired up to a server that signs a transaction, yes, or signs a message saying then on chain that yes, we'll pay for that particular transaction. So let me give you the make sure that's the right one. Okay, cool. So this is going to be the gas policy ID. So what we'll pass into here is going to be something called gas manager config is the name of the field. Yeah. And then this is going to be, yeah, perfect object. You guessed it. And then policy ID is going to be the, yep. And then this you can pass in exactly that. Perfect. And now this is going to sponsor the gas. So cool. So we did that. And now we just need to change over the send transaction piece, which for that, we're going to call this, instead of client send transaction, there's going to be a new method on this client that's specific to the SDK that's going to be called send user operation. Yeah, sweet. And so send user operation actually takes a bunch of higher level stuff as well. So it has some other fields that we can pass in here.
One second. I don't know why this keeps happening.
Create modular Alchemy client is it's asynchronous. So that is the difference between the VM one. That's probably why I thought it was asynchronous initially. So on line 14, we'll probably just want to await there, or you could let it do what it wants to do.
Okay, so we want to await it here.
Yeah, so yeah, exactly. Yep. Yeah, so that is a good difference between the two. And then we could do send user operation. Cool. And so one thing that you will have to do for this is you are going to have to wrap what was like the transaction fields inside of there's a field called UO, and UO is going to specify the user operation. So if you just create like a field called UO, and then we could open up object, and then we could put the 2 in the data inside there. Yeah. And then you could put
the data.
Yeah. Both the 2 and the data can go inside there.
Okay.
Sweet. Okay. So the one thing that is going to change too is 2 is going to become target. That's the only other thing that we need to change there. And then we are golden, I believe. Okay. So one thing I should point about the UO here is you could pass in just one UO, or you could pass in many user operations. And that's like pretty similar to the question that was just asked about like sponsoring gas and really cool thing about the bundler is it's called a bundler because it takes a bundle of user operations. So you could take a bunch of user operations, put them into one transaction, and then put them on chain. And we could get some cool gas savings from there. There's all kinds of research on like optimizations and things that can be done in that regard. So that's another really cool feature of account abstraction there.
So if I were to want to do multiple operations here, how would I go about doing that?
It'd be an array with objects of the same fields. So you could do increment. You could actually do increment twice here if you wanted to. And then we could, let's just do that.
Let's do that. Yeah. Cool. So UO would just become an array?
Yep. Mm-hmm.
Okay. I think okay.
And then we can just do
so
that
that
twice.
will just increment twice.
Perfect. Yeah, that should work perfectly fine, I think. Yeah. Okay, sweet. So so what the send user operation is going to get back is I don't know. Let me see, what is the documentation? I don't know if we get the user operation hash back. We can see. So let's see what it says it returns. No, it returns a user operation result. So if you want to just call that result, and then the client has a method called wait for user operation transaction. So we could do this after that, where we could say like, so we can get like we could call this like const hash is equal to, if we don't already have a hash, we might, no, we don't. Okay. And then we could say client.wait for user operation transaction. And then we should be able to pass in that result, I believe.
And this should be awaited?
Yep. Mm-hmm. And then that hash should tell us that indeed the transaction landed on chain, because again, these user operations are getting bundled, right? So this will be one transaction here. Sweet. All right. So we should increment twice if this all works out the way we expect it to. And that private key, we'll do something cool in a second. I'm nervous.
All right, something happened.
Whoa.
The hash.
Let's go to increment. Let's go to the count. Is the count 3? Oh, man, if it's 3, we did it.
It is 3.
Yes. Whew. Oh, man. I always feel like it's never going to work.
It worked the first try both times. That's amazing. This has never happened before.
So, all right. Really cool thing that you could do here now, which is awesome. We could do right on stream that private key that we have there up at the top.
Mm-hmm.
Now, that's just an authentication private key, right? At the end of the day, like, that private key doesn't need to have gas inside of its account. It does, but the gas policy is paying for the gas here. So technically what you could do right now is generate a new private key. And that private key we don't need to do anything with. We could just start using it and creating a new smart account for it. So the brand new private key, never been generated before. Me and Rahad are not in cahoots. And
as everyone saw, I reran that script.
So now we can actually send this through, and hopefully now it'll be 5, right? So we're and behind the scenes, we'll see this in a moment. Behind the scenes, we're generating a whole new smart account for this private key.
It is 5.
Yes. All right. So now what we could do is we could take a look at that transaction hash that came back in the console there. And maybe what we could do, so this is a new transaction hash. So something that's interesting to point out about, and we'll see this in just a moment. I know we didn't do too bad on time. I'm going to show you a starter app, and I have it locally, so we won't take too much more time. But we'll see this in a moment. It's really cool. You could just have Oh, right. Okay. Lost my train of thought for a second. So the idea is with users, when you first log into a smart account, we can counterfactually figure out what your address is going to be. So what I was trying to say is that you don't actually create the smart contract account until you actually go to send user operations. So here Rahat has pulled up the actual transaction, and you can see some of the events that are occurring in here. Things like the account was deployed. There's also above that, there should be like installation stuff. So you can see there's a modular account initialized and a plugin installation. So this particular client that we set up here is a modular account with a multi-owner plugin installed. So the idea there is we could have actually specified multiple owners into this account. We only did one in this case, but we could do multiple owners if you wanted to have multiple people who could sign on behalf of this account. And that's going to be installed by default. So you could see here that there's only one owner added in, and that's going to be the signer that we're signing with, that random private key that Rahat just generated. But this is all happening behind the scenes before sending that user operation. So we're creating a new smart contract account. Now, every time that we go to send a new user operation from this point forward with that private key, it's going to reuse that same smart account. So we won't reinitialize the smart contract account. But this particular transaction we did, and then we also sent those two increments, two user operations inside of one transaction to increment it twice. Sweet.
Cool. This is awesome. So with the Alchemy account kit, then it's kind of like almost like a one of X multi-sig out of the box.
Yeah. So we also have so this is a multi-owner plugin, and then there's also a multi-sig plugin that I believe is going under audit. So the difference there would be the multi-owner, for each owner you have full privileges, whereas a multi-sig you could potentially do like what you described, which is I need this many signatures to actually sign off. We also have like a session key plugin. There's also a number of plugins that are being developed by many different companies now that are like creating these and just adding them. So like, hopefully very soon there's just going to be an ecosystem of many, many different plugins that you can imagine. So subscription plugins, being able to subscribe to something and then be able to pull payments out of your account. If you wanted to do some sort of a subscribe payment. And session keys is like this idea that you could create a key that is limited in scope, both for what it can actually accomplish and for how long it lives for. So you could imagine like coming into an application and you just want to say like, I just want this key to have access to my one NFT for 20 minutes. You can actually program that into your smart contracts now, right? Nice. And be able to, from that point on for the next 20 minutes, maybe you could do whatever you want with that asset, sending it here, changing some of the attributes. I don't know. Whole new world that we could possibly do with some on-chain stuff now. So.
Yeah. Nice. So we wanted to show the starter kit that you had, right?
Yeah. So the last thing, we can jump into it real quick. I don't want to take up too much more time, but I do have a starter kit here, which we can provide a link for. And the starter kit, what it is it's basically everything that Rahat did here, but put into a web application so that your users can just sign in with an email address. And then from there, they can just have a smart contract address associated to it and just start making user operations on chain. So what would be cool is if from the application that I'm about to show you, we could also increment, and then I'll call out to your smart contract address and we can increment from this UI. So let's do that. Cool. So I'll share screen over here. Okay, so I have this up on localhost 3000, but in case you want to find this is and it's getting more polished as we speak. I just started this one yesterday, so you may come and you may see that it looks a lot better than it currently does now, but you can find this currently at Alchemy platform /AA starter. We're going to be polishing this up and making it a whole lot better, but for now, this is a Next.js app that you can log in as a user. And what I like to use for this example is there's a service called TempMail, which is very ad ridden, but it's a sweet service in that it gives you a temporary email address, and we can just sort of wait for it. We're getting advertised Garfield. Does Garfield have a new movie? Okay, there's my new email. Feels like Garfield had a lot of movies.
Yeah.
Right, so there we go. So we sent over. So in my app here, I'm so used to just testing this that I just clicked it very, very quickly. I went in to log in. I clicked my email. Now it's sending an email sent on the way, so I can log in over here. And in just a moment, hopefully we'll see this email come through. Any minute now. Come on, don't fail me now.
This is longer than a blockchain transaction.
Temp mail, come on. It never gives me this trouble. Oh, bummer.
It's probably only because you're on a live stream.
You know, this always seems to happen with it. All right, let me send it to my email address, and then I'll do that off screen because I don't want you guys to see my emails. I don't know. I don't know what's in there. You know, it's nerve wracking. All right, so let me do this. I don't know why. Unfortunately, temp mail's always been very reliable for me, but maybe not this time. Okay. All right, we'll try again. So log in, and I'm going to do, now you guys know my email. All right, don't spam me. So I sent that through to my email, and
You're
I
about
should
to be signed up for like a million things.
Hopefully this will come through in just a moment. Oh, no. Okay. Maybe the emails are just not coming through. Did I change something just beforehand? Uh-oh. 500. Oh, goodness. What did I do? Maybe I was testing something? Did I do something bad? Oh, there's a sign up 500. Whoa. Okay, that's interesting. I'm going to screenshot that or copy that over just to see what's going on there. That's an interesting error. I'll have to test that out. I must have been playing around with something, but I'll do it on screen. So now what I'm going to do is I'm actually going to go ahead and change my my account information so you guys can actually see that. For whatever reason, I think there's something wrong with my project. It's like bugged. It's because I'm doing too much testing and just messed it up here. But we'll jump in here and be able to see actually what's going on behind the scenes. And I'll pull over my code as well, just so I can. Whoop, this is the one here. Sorry, this will only take just a moment. And we'll have a .env. So I just need an API key and a policy ID. So this is going to, I'm actually using the same one that I was, let's use this. So which one was I using? I was using this one here. That's probably this one. All right, let's use this one. So I have two Arbitrum Sepolias. I'm going to use the second one because for whatever reason, I don't know why that would matter. But I just gave you that one. I sent it over to you, and that one was working at least before. I'm just going to use this one. So this is the gas policy that I was talking about a moment ago. So in the gas policy, you can actually specify things like per address rules and per user operation rules. This is your paymaster and whether or not you want to actually sponsor the transactions. And then the other thing that we'll actually see increment back here, these are the signatures that are actually coming from our, we use Turnkey behind the scenes that's doing signatures on the user's behalf. So this is actually managing the private key here. So you can actually see these signatures increase as we're doing more on-chain actions. So we do have to wire this up for our specific applications, so that way we can get this working. And so I'm going to go ahead and pull over my gas policy ID, and we'll put this in here. And hopefully with that, it does say that it reloaded my .env, but you know what? I never believe it. And we'll pull it up, and we'll jump.
I also never believe that.
It never works. I swear. Yeah. Either that or we're always debugging something, you know, so like you always doubt it. And then, yeah. All right. So let's see. Give this a moment to come through. All right. Sweet. So maybe temp mail was, you know, I besmirched temp mail as if temp mail was the issue. Temp mail has never let me down. So I apologize, temp mail, if you're watching. Didn't mean to. That's the same email that I got before, isn't it? All right.
I really want some pizza now.
Gonna go watch Garfield and eat some pizza after this and go to New York City. Oh no. Oh my goodness. You know, we did such a good job on the first part that I shouldn't have stretched it and tried to get the starter app in here. It looks like I'm getting the same error.
Okay.
I apologize. I was just working on this yesterday. Unfortunately, we're not going to be able to finish this last part of the demo here. I'm going to have to figure out what that error is.
Cool.
Must have been something that I was working on last minute. That's a bummer. The way that this application should work, though, is you log in with an email address, and then you could start sending user operations with the address. We will get this working. So if you do go to the AA starter soon, you'll be able to use this without the issues that I'm running into now. So apologize for not having that ready for the live stream. You could see that I was working on this late last night if you look at the commit log. So must have messed something up. But yeah, we'll get that working.
Cool. Awesome. No, we still got some user operations working for the increment. So I think that in itself is a win. And I'm still in awe that it worked the first time we ran the code.
Yeah, me too.
I haven't gotten over that yet.
I was very happy about that. And usually that app that I was showing works really well too. I was like, man, this is going to be a runaway. But
we can't be lucky on everything.
I got greedy.
Yeah.
Try to get 2 demos in one day. The demo gods were like, no.
No, absolutely not.
Well, thanks so much for having me on your show. This was a great time, and glad I got to give you a little performance anxiety and put you through the ringer as all your guests do. I still can't believe you do this. It's it seems very
it's something that I've told myself many times in my career that I will never do again, and I'm like, that's a lie. I'm gonna do it again.
I'm sure you learn a ton, right? I
Yeah.
only watched the one video of you doing it, but like it's great to have people come in here, show their particular technologies and be able to learn them. So that's super cool. Thanks for having me.
Definitely. Thanks, Dan, for being a part of this. For folks tuning in, we'll be announcing the next episode next Monday, as we do every week. We also have another special announcement. Protocol Explorer has been accepted into the upcoming Gitcoin round. So we'll be posting a little bit about that, some announcements there of how you can participate in that round. So thank you all for the support so far. Thank you, Alchemy, for being on this episode. And we'll have some more coming up for you.
Awesome. Thanks so much, Rahat. Thanks, everybody.